All right, thank you. So first, a little bit about myself and Carpe Diem Technologies. We've been around for about 20 years, and we're kind of a niche business. We've really focused on solving difficult technical problems. I mean, that's basically why someone would come to us as opposed to maybe one of the bigger players, okay, out there. And one of the areas, well, you see the LED beacon on World Trade Center. That was one that we worked on a while back, but we got involved in roll-to-roll nano imprint lithography starting in about 2010 with a NSF program with UMass, and gradually we've been tackling different problems associated with nano imprint lithography for roll to roll for the last 15 years. And for the most part, people have this idea, a brilliant idea that can be done on a wafer, and it'll be super cheap if you go do it in a film. Okay, but now there's a gap. Okay, with how do you go from that wafer idea that you had that you proved out in the lab to a big piece of equipment or something that can scale. And for the most part, that's where a lot of projects die, okay, is going and trying to cross that gap. And we saw that. And so we've been working for the last few years trying to plug those areas and work on the enablers, and whether it's enabling IP or some just missing piece. And so that's what we're about. And so initially, we were working on these roll-to-roll systems as a UV nil system that was in a lab in the University of Minnesota on the lower right. And we started seeing that okay, making those masters was the problem. So we started working on making masters. And then we realized, well, actually using the system was the problem. And so now we actually started working on application support. Okay, and so now that's really become the focus of our work, and you can kind of see an example of a film being replicated in one of our systems. And so now, well, why nil at all? And the real thing there is that you have a resolution that could be down to 10 nanometers. Okay, that's really and in principle really inexpensively for production. Okay. The other part of it is that it can be integrally self-aligned. You can create these 3D structures. If you can get the stamp or the master, you don't have to worry about registration. You can just go ahead and run. Okay, so that has the potential for making it inexpensive. And of course, higher resolution than inkjet, flexo, gravure, screen print. And we know those are all important technologies for printed electronics and that. But if you want to take it another level, nano imprint may be a way to go ahead and do that. And as I said before, it's one step 3D. Okay, and so you'll see in a minute why that's important. And it's really important because it's applicable to optics. Okay, and so optics by its nature is sometimes demanding a little 3D. And as I point out, also metamaterials, fluid electrical devices, and that. And yeah, and finally, you can go to large area, you can go stamp to wafer, roll to roll, you can do sheet fabrication. So there's a lot of potential applications. And those potential applications have generally, we've seen over the last several years that they fall into a few categories. We see optics examples, okay, and there's some examples of some wavelength optics and basically some idea of dimensions, but also microfluidic channels. Okay, and these microfluidic channels, they could be carrying ink, they could be carrying sweat, they could be carrying any number of fluids. And when it carries ink, that could be conductive ink, and that so it can be part of a step in fabricating the device. And then finally, there's sort of the metasurface or metamaterials. And the metamaterials, we've worked with a lot of customers now over the years, and they all kind of look the same. The metamaterials basically tend to be a bunch of pillars, okay, on a surface with some really important dimensions. Okay, and those critical dimensions will actually define